Enthalpy is directly related to the heat. So because of that, enthalpy is also known as heat content. Okay. Now any chemical process or various physical process also involves heat. All right. So a process in which the heat is liberated from the system, we call it to be exothermic process. Okay. And that is being indicated with minus delta H. This is exothermic. Exothermic process. Okay. And the process in which heat is absorbed by the system. Okay. So we indicate it by generally you don't put plus. Anyway, plus delta H, this is called endothermic process. Now, I'm going to talk about something is called heat capacity. And for information, in your syllabus this year, heat capacity is not being involved. I do not know why. It is such a small portion. Anyway, it is up to the board to decide. So, heat capacity is not involved. So what is heat capacity? See, it is the amount of heat required to raise the temperature of a system by 1 degree. See here, it's now the question of Kelvin or Celsius because amount is always same. Okay? It is denoted by C, capital C. Okay? So now we can write. Therefore, heat capacity is equal to heat absorbed divided by temperature. Okay, now we know heat capacity is what? Therefore, C. What is the symbol of heat? Q. And this is the temperature. So this is the symbol of this. Now, it can be classified into two categories. Okay, that is, I can increase the heat of a system either under constant pressure or under constant volume. Constant pressure, suppose say during winter you want to take bath with hot water. So you have started heating water. Or it is an open system. So the pressure is constant. Atmospheric pressure is not changing. Or you can do where you have heated water in a closed system. Okay? That is, in that case, it will be constant volume. Okay? So heat capacity determine at constant pressure. Now, heat capacity determined at constant volume. Okay. Now, what is the symbol of heat capacity at constant pressure? Cp. And this is called Cp. Okay, now we can write that Cp is equal to Qp divided by delta T. Or you can write that Qp is equal to Cp into delta T. Similarly, we can write okay, see now, we know at constant pressure Qp is equal to delta H, that you have already done that day. So therefore you can also write that delta H is equal to Cp into delta T. Similarly, we can write Cv equal to Qv under delta T. Or you can write that Qv is equal to Cv delta T. But again we know at constant volume, okay, delta V is equal to 0. All right. So in that case, it will be equal to that Qv equal to delta U. See, some of you don't understand, also keep quiet. Remember, delta H is equal to delta U into P into delta V. When at constant volume is what? Okay. at constant volume delta V is equal to 0. Therefore, what? Delta H is equal to delta U. But we know delta H is equal to what? C only. So, because of that, we write here. Sorry. Delta H is equal to Q. So, condition is what? Constant volume. So, QV is equal to delta. So, because of that, I'm writing it. Relation between CP and CV. Okay. So now we write here. CP is equal to QP divided by delta. CV is equal to QV divided by delta. Okay. So this is equation 1. This is equation 2. Okay. We know that QP is equal to delta H and QV is equal to delta U. Therefore, we can write, therefore, CP is equal to delta H divided by delta E. And CV is equal to delta U by delta T. Equation 3, equation 4. Subtracting equation 3 from subtracting equation 4 from equation 3, we get CP minus CV is equal to delta H by delta T minus delta U by delta T. We know delta H is equal to delta U into P into delta V. Therefore, CP minus CV is equal to delta U plus P into delta, P into delta V divided by delta T minus delta U by delta T. LCM is same. So delta U, P into delta V minus delta U, delta T. This and this will get cancelled. Therefore, what we get here? CP minus CV is equal to P into delta V by delta. Okay, right after this, then I'll continue. কোনো কষ্ট করিস না।
Sir, done.
Okay, very good. Now see here. The easiest portion of thermodynamics they have removed it. Okay. See here. For an ideal gas, PV is equal to NR. Okay. So now we can write. See, if the pressure is constant, how the volume will increase? We know if the pressure is constant, volume can increase if there is a change in the temperature or a temperature increases. So we can write that P into delta V is equal to NR, because N is constant, R is constant. Is equal to. So let me write here equation 5. So we write now here, substituting the value of P into delta V in equation 5. We get Cp minus Cv is equal to N R delta T by delta T. Okay. So this and this will get cancelled. So therefore, Cp minus Cv is equal to N. This was a very popular derivation for thermodynamics for classical students. Okay, now there is a number of moles of gas, so we can write now here for 1 mole of gas means what? N is equal to 1. This is equation 6. 1. The equation can be written as Cp minus Cv is equal to R. See, R is a constant. R is a constant, is a positive quantity. So when the difference can be positive quantity? Only when the Cp is greater than Cv. As R is a constant and a positive quantity. Okay, therefore Cp is greater than Cv.
So done.
Now, what is specific heat capacity? Mind it, heat capacity is an extensive property. Please try to understand, don't by heart. Why it is an extensive property? Because it depends upon the amount of the substance they are supposed to heat. If you want to heat a small amount of substance, you require less amount of it. And if you want to heat a large amount of substance, in that case, you require more heat. So please remember that heat capacity is an extensive now specific heat capacity. It is a different definition is same only. Only in case of specific heat capacity, we have to write 1 mole of substance. See here. It is the amount of heat required to raise the temperature of 1 mole of substance. So what I can write now here? Okay. What we can write now here? Specific heat capacity is equal to heat absorbed divided by rise in temperature into molar mass. Specific heat is an intensive property. Why? See here. Here it is always expressed per mole. How much amount of substance you have taken, but the express is per mole. So in that case, it is an intensive property. Okay. These are expressed as Cp bar and Cv bar. So these are the symbol of specific heat capacity at constant pressure, specific heat capacity at constant volume. Some enthalpy changes. Enthalpy changes in physical process. In physical processes. What is the physical process? See, we have to convert solid into liquid. So in that case, heat is required. Then liquid into vapor, some amount of heat is required. Then there are some substances which you can directly convert the solid into vapor. Okay. So some heat is involved. Now, whenever you make a solution, in the process of solution, you find some heat is either absorbed or released. So heat is involved. So all this you can measure per mole under standard states. Means it should be at 298 Kelvin and under a pressure of 1 bar. Then this we call it as standard enthalpy changes. All right. So let us start one by one. So we'll write down here 1. Standard enthalpy change. No. In conversion of solid to liquid. Okay. What do you call this? In one word, what do you call it? Or we call it standard enthalpy of solution. Okay. And its symbol is delta H0. Whenever we put 0, it is called standard. Here we write FUS. So it is the enthalpy change in conversion of 1 mole of solid substance into liquid under standard state. Means at 298 Kelvin and 1 bar pressure. This is this. Mind it. When you convert solid into liquid, we call it fusion. And when you convert liquid to solid, we call it crystallization. All right. So here the magnitude of both of them is same, but the sign before the enthalpy is different. When a substance is being converted into liquid, in that case, heat is absorbed. It's an endothermic process. And when liquid becomes solid, whatever amount of heat is required to convert solid to liquid, same amount of heat will be liberated. So that process is exothermic. All right. Now, what should we do right now? It is denoted by delta FUS is 0. Okay. Second, standard enthalpy change in conversion of liquid to vapor, or what we call it, standard enthalpy of vaporization. Okay, so we'll call it here delta VFP 80. So it is the enthalpy change in conversion of one mole of liquid, to vapor under standard state. So I'm not writing standard state, meaning you already know. So we can put a full stop. Under standard state, it is denoted by delta VFP 80. Standard enthalpy change in conversion of solid to vapor. We know what is the name of this process. We call it sublimation or standard enthalpy change of sublimation. What should I write now here? SUB. Okay. So it is the enthalpy change means energy change. Enthalpy change when 1 mole of solid is passed into vapor state without going through its liquid state. Okay, we'll write here now sublimation. Under standard state. Okay. It is indicated by delta H. You finish writing, then I'll tell you something. See, I don't write. Solid supposed to become liquid. And liquid is supposed to become vapor. So what is this? Here it is delta H fusion. Oh, sorry. Energy involved is what? Energy involved is what? This. This is a normal process. In this case, what has happened? It has directly gone here. Sublimation. What is the energy in here? This. And when you have calculated, we have found this value is exactly equal to the sum of both the values. So it is found that delta sublimation H0 is equal to delta fusion H0 plus delta vaporization H0. Mind you, it is being calculated. Drama pipe লাগছে পাইপটা দিয়েছে পুরো জল পড়ে গেছে তাই
খুলে গেছিল
হ্যাঁ করবো তো এখন পাইপটা তো এইরকমই কিছু না ড্রামের পিছন দিকে ওকে নাও Enthalpy change in solution. Okay. Is the change of enthalpy when 1 mole of a solute is dissolved in solvent under standard state. Okay. So now right here it is denoted by
Yes, sir.
okay. Now the standard enthalpy of solution depends upon the nature of solute. It can be either positive, that is endothermic, or negative, exothermic. Okay. Example देखो. Suppose you have dissolved potassium chloride in water. Okay, this is solid. What will get in the solution? How should we write now? Express this equation. We'll write here it was. Okay. This is a aqueous solution of potassium chloride. See, in this case, what has happened? You will find delta H solution is 18.6 kilojoule. You know what will happen? After dissolving, you put your finger in the solution, you'll find the temperature of the solution has reduced. It has become now cold. All right. So this is an endothermic process. Endothermic process. What is the meaning of this? Huh? The meaning of this means if you want to dissolve potassium chloride in water, you have to heat the solution. Otherwise, its solubility will be very less. Same thing is applicable for sodium chloride also. But if you have taken here copper sulfate, okay, and you want to dissolve the solution, in that case, you will find copper sulfate aqueous. Here you will find delta solution H0 is minus 66.5 kilojoule mole in water. So it is exothermic. You'll find the solution has become warm. Could not give you because I don't have this value. If you put sodium hydroxide solid in water at room temperature, there you will find the solution is boiling. Okay, so much amount of heat is generated. Same is the case of concentrated H2SO4. If you put it in water, okay, so much of heat is generated, it leads to explosion. So the dilution of sulfuric acid, we never add sulfuric acid into water in bulk. Okay, we add drop wise with lot of cooling. So this is the enthalpy of solution. Okay, now let us look something little more. See, we should not have a feeling that all salts are ionic and all salts should be soluble in water. No, that is wrong. Many salts are not soluble in water. Many salts. Why it is like this? See here. When I have taken a crystal of a salt, okay, in crystals you will find millions of particles are packed in a systematic order, okay, and it is given a definite geometric shape. So here the molecules of the ions are tightly packed inside the crystal because of very strong force of attractions. All right. So now when you drop this one, into water, what you have to do? These particles can go into solution only when you break the wall. Suppose you have kept your clothes inside a suitcase and you have lost the key. So in that case, if you have to get your cloth, then you have to break that law. So similarly, how to break this crystal? Only when you overcome these forces of attraction. Okay. So how much amount of energy you have to supply? You have to supply the amount of energy by which they have formed that crystal. And this wall of the crystal is called lattice. Lattice. And the energy is called lattice enthalpy. Okay, so amount of energy which is released in formation of the crystal, same amount of energy if you supply, then only you can break the crystal. Okay, suppose you have broken the crystal. And these things you have separated. They are now in water. When they go into water, and if they find they are not comfortable with the new environment, that is, water molecule did not give them support. Suppose, say, after class 12, you went out to study. So when you go out of the house, you feel very, very sad. You develop a sense of insecurity. So your parents have put up you in a hostel. When you are being put up in a hostel, then you find a new environment, everything is new to you, do not know, and nobody is helping you to introduce to different systems. Not only that, they are creating a lot of problem in your life, which we generally call it ragging. The environment is very hostile. In that case, what you do? If it is too severe, again you come back home even for checking your career. Or you may find a better place to stay. All right. So when you dissolve a substance in water, in that case, say you have taken sodium chloride, you have broken it, separated into sodium and chloride. In this case, sodium and chloride has to be stabilized by water. Ions individually are not stable. They are individually not stable. So what water will do? I think I have told you also. See, this is polar. In that case, what will happen? Water molecule is going to give them support. See here, this is a positive environment is being surrounded by water molecules. So now, in that case, what happens? Sodium as ion does not feel the deficiency of its electron, because it's found is being surrounded by electron cloud. So it happens sometimes you might have gone to school and in a hurry you forgot to bring the tiffin. And nearby school you may not have any place to eat also. During this pandemic period, all canteens and everything are being closed down. So you will feel shy to take tiffin from your friends. But you have, during tiffin hour, you told them that today I forgot to bring the tiffin. So immediately 5 or 6 of your friends, they will give you something to eat. Same is the case here. See here, sodium ion is being stabilized by the electronegative oxygen. What will happen to the chloride? No problem. Chloride will be supported by this other end of the water molecule. So the water molecule by hydrogen, they are going to surround. So this process is called solvation. In case of water, we call it hydration. Okay. So you will find that enthalpy of solution is sum of the lattice enthalpy and hydration enthalpy. Okay. If you find the lattice enthalpy is more than hydration enthalpy, So in that case, what will happen? Water molecule cannot break this crystal. And if they cannot break the crystal, in such case, the substance will not be soluble in water. So please remember, never have a feeling, because theory and practical is different. We are being told like dissolves like. So the polar substance or the salt should be soluble in water. Theoretically, is perfectly correct, but we do not know the inside story. Inside story is that it depends upon the ions which just make the crystal salt. Okay, so when lattice enthalpy would be more, lattice enthalpy will be more if the charge on cation and the charge of anion is very high, so the attraction also will be very, very high. In that case, water molecule cannot separate them. So this lattice enthalpy will be higher than hydration enthalpy. This type of salts will not be soluble in water. Now, if the hydration enthalpy, okay, in that case, how to dissolve them? In that case, you have to supply heat. When you supply heat, then the water molecule along with this energy and the energy borrowed from outside only can break the crystal. So those type of solution will be endothermic, or you will find the temperature of the solution will go down. Why? Because this water molecule is going to absorb heat from the surrounding. So that has been endothermic process. But if the hydration enthalpy is much more than the lattice enthalpy, in that case, what will happen? Water molecule will easily break the crystal. And what will happen to the extra energy it has? It will give out to the surroundings. In that case, you will find that the solution has become warm. Please remember. Now we go for enthalpy of neutralization. Though it is a chemical process, but I'll put under physical process. What is neutralization? It is nothing but a reaction between acid and bases. So right now here, it is the enthalpy change when 1 mole of an acid reacts with 1 mole of base to produce salt and water. Okay. It is denoted by okay. See, we know there are two types of acids and bases are there. Strong acids, strong bases, weak acids, and weak bases. In all strong acids, the enthalpy of neutralization is same irrespective of acid, whether you have taken hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid, all of them will find the value is same. The enthalpy of neutralization of strong acids and bases is minus 57.1 kilojoule mole inverse. Enthalpy of neutralization of strong acids and bases is 57.1. Please remember. It is HCl, sodium hydroxide. Okay, so you will give you NaCl water. Here, the enthalpy is H0 is minus 57.1 kilojoule mole inverse. Suppose you have gone for, because we always find per mole. So if I have taken sulfuric acid, okay, so it is, see here you require 2 molecules. So per mole means you have to divide it by 2 to give you sodium sulfate and 2H2O. Here also you will find the enthalpy is equal to minus 57.1 kilojoule mole inverse. So ultimately what I can write? I can write H plus aqueous Here also you write aqueous. H plus H minus aqueous is equal to H2O air. Is equal to what? Delta H0 minus 57.1 kilojoule mole inverse. Now see for weak acids and weak bases. Bases. The heat of, this is also called heat of neutralization, okay? The enthalpy, or you can write here heat of neutralization is not equal to minus 57.1 kilojoule mole inverse and are less than minus 57.1 kilojoule mole inverse. The reason is that they do not dissociate completely. Okay. If I have taken here 1 mole of acetic acid, see, for strong electrolyte we put direct arrow, and in this case what you will find here, the dissociation is very less. So here you will find is less than 1 mole. Less than 1 mole. So this is for 1 mole. See here, it is 1 mole. This is 1 mole. So value is for this here. Value is here the concentration of the H plus ion is less than 1 mole. So in that case, but question is that why the value should decrease? Yes, value should decrease because less rest of so whatever amount of heat they generate, some amount of heat is being required to complete the dissociation. Okay. So as weak acids and bases undergo incomplete dissociation. So some amount of heat generated in neutralization is used to complete the dissociation. Okay, hence the enthalpy of neutralization is less than minus 57.1 kilojoule mole. See here, acetic acid, sodium hydroxide, to give you sodium acetate plus water. Here you find enthalpy is minus 55.9 kilojoule mole. It is 57 minus 55.9. This much amount of energy is required to complete the breaking bond of between oxygen and hydrogen.